You've just cloned a massive new AI project. You type pip install, hit enter, and wait for the magic. But instead of a clean progress bar, you get a wall of red text. Right at the bottom, hiding in the wreckage, is a specific message: error, resolution too deep. It is easy to assume the code is broken, but 9 times out of 10, the code is perfectly fine. What actually failed is your environment setup. There is a common misconception when starting out, assuming that if you use the terminal to navigate into a new project folder, your computer automatically switches its brain to match that project. It doesn't. Your terminal is an independent program. You can walk into the physical folder of your heavy AI project, but if you don't explicitly swap out the active environment, it's still operating on whatever rules you gave it last. When you force a terminal to process conflicting, heavy instructions meant for an entirely different workspace, your system panics. You spiral straight into dependency hell. To fix this, we need to look at the tools we use to build our workspaces, starting with Python's built-in option, Venv. Think of Venv as a portable toolbox. When you create one, you drop a self-contained, isolated workspace directly into your current project folder. It operates with strict limits. Venv only understands pure Python, completely blind to external system drivers. If you try to stuff a massive AI dependency that requires specific C++ compilers into that little toolbox, it literally will not fit. Because the necessary underlying system architecture is missing, the installation crashes, usually throwing a long, incomprehensible compilation error. For a simple web scraper or a lightweight API, Venv is exactly what you need, but it completely lacks the jurisdiction to manage the heavy, hardware-level architecture that is required by modern deep learning. That jurisdiction limit also applies to how these environments download software, which brings us to pip versus Conda. By default, the pip installer is designed to hand you raw ingredients. It downloads the source code and expects your local computer to act as a factory, compiling everything on the spot. If your machine lacks a specific C compiler, the local assembly line jams. Pip wheels help, but they are strictly limited to Python code, ignoring external system software. Conda takes a completely different approach, delivering fully assembled, pre-compiled binaries, like pre-cooked meals. Conda easily handles software outside the Python ecosystem. It will gladly download and install FFmpeg for audio processing, Node.js, or NVIDIA CUDA drivers for your graphics card, right alongside your Python logic. Because everything is pre-compiled by Anaconda before it ever reaches you, a Conda environment behaves identically across Windows, Mac, or Linux. You bypass the nightmare of local compilation entirely. Conda ensures the components you download are already assembled and guaranteed to be compatible, which brings us back to that ResolutionTooDeep error. To understand why it happens, we have to look at how these tools solve puzzles. Pip is built for speed. It uses a linear backtracking algorithm. It installs package A, moves to package B, and if it suddenly realizes B requires an older version of A, it hits a wall. For complex AI, pip gets stuck in a massive loop of trial and error until the system crashes. Conda relies on a SAT solver. Before downloading, it maps the entire dependency web, calculating a unified path where every constraint is satisfied simultaneously. You wait longer for Conda to calculate the environment up front, but you trade that waiting time for an ironclad guarantee against impossible conflicts. There is one more physical difference you need to understand, and it's a common rookie trap: where these environments actually live on your hard drive. If you create a Venv, you know exactly where it is. It lives locally, directly inside the project directory it serves. But Conda defaults to acting as a centralized armory. It stores your environments in a hidden central directory on your machine. When you activate a Conda environment, that armory beams the required logic down to your terminal. Your physical folder location doesn't matter to Conda at all. Because of this centralized architecture, if you finish a project and delete the source code folder, the heavy Conda environment associated with it is still sitting perfectly intact on your hard drive. How do you choose? We can map this onto a matrix based on dependency weight and jurisdiction. If you build web backends, simple scripts, or pure Python projects, Venv is your tool. For heavy AI, local language models, or complex C++ dependencies, you need Conda. The trade-off is straightforward. Conda guarantees hardware stability, but requires massive amounts of disk space. Venv requires almost zero disk space, but offers no hardware-level support. Regardless of which tool you choose, your strongest defense is the look left rule. Before you ever execute an install command, physically look at the far left side of your terminal line. Verify that the name inside those parentheses matches the exact environment your project requires. Validate your environment before acting. This is the highest return habit you can build. Master it and permanently avoid the dependency disasters holding your projects back.